New for 2022, this is my new do-it-yourself dual track high current Wi-Fi remote PWM controlled train controller. The main box, I can pop the lid off, is clearly DIY. We have a nice high current 24 volt power supply, a Wi-Fi receiver. Inside the blue box are two Arduino Nanos, which provide low-level control for these pair of high current H-Bridges. Inside the little red boxes are some buck regulators to give me the low voltages that the Arduinos want. On the back side of the box, stereo speakers for the track connections, extra holes for future train polarity switches. On the front of the box, a green light and a red light. The green light tells me when the server is running. The yellow light tells me when the server is connected to one of the remotes. On the side, we have a power switch and a power indicator. And as we can see, the green light is blinking. So the server is running. The remotes are 3D printed plastic boxes with some old phone external batteries that have been repurposed. I've got the screws out of track 2 so I can pop it open. There happens to be power switches on these guys. So the main features of the remote are that the track control is this clickable rotary encoder. So I click it and the train is in the stop position, and when I rotate it, there are detents on these encoders. As I rotate this knob, push this, we can see these together. You can see the activity on the yellow light increases. So this is a matching 8266, just some really basic client-server Wi-Fi implementation. This does not connect to my home router, though it can. It can be internet-enabled, but I'm not really too excited about that right now. So pretty happy with my 3D printing. That was the second shot of the box. Of course, the first try of everything is a fail. And so track 1, I can click to stop. I can make it go backwards. And notice that the red LED flash rate increases with the speed of the train. So in case the train isn't running, you can see how fast it thinks it's going, roughly. So other things that were important to me are with young grandchildren, my previous system, one turn of the control went from 0 speed to full speed, and small hands have a tendency to ramp the train really fast. So with this, there are about 4 revolutions of the encoder before you get to max speed. So you can't inherently slam it from full reverse to full forward. There are other features in here as well, actually implemented in the Nanos internally, is an acceleration deceleration parameter. So if I am going max reverse speed, for example, and I click the button, the controller immediately goes into stop, but the Nano decelerates the train in a polite way. There are some timeouts that are really handy now, so if I'm running the train outdoors and I don't change anything for 20 minutes, then the trains will shut down until you come back and do something at one of the remotes. So for me, this is a huge step forward. It is not DCC. It is analog PWM, and I know analog and PWM is kind of an oxymoron of sorts, but the PWM is now running at 8 kilohertz, and so when you look at the impedance of the motor and the way the train is driven, it's for all practical purposes an analog drive. My old system was a single track wired system that ran in about the 600 hertz range on an old 555 timer with a a toggle switch that controlled a double pole, double throw relay. It was all very, very clunky. Also ran on an 18-volt power supply. This power supply is a 24-volt adjustable supply. And my latest addition, which is this USA Trains Conrail engine, in the directions, it speaks of a maximum voltage of 22 volts. I've seen a lot of references on the internet to G-scale trains running 24 volts into 22 volts. And finally, I found a piece of documentation that supports the notion that at least one manufacturer recommends 22 volts maximum. Not really sure why they did that, but I adjusted mine down to 22 just to be safe and happy. So the range on the Wi-Fi is really, really terrific. The box will stay outdoors, which is another big improvement for me. I did make a plastic using Home Depot PVC sheet material. It's a little bit overkill. I made this cover that I can cover the whole thing up with. Sorry about the camera. And I'm not going to put the mouse hole in for the cable just yet, but that will keep it nice and dry on bad days. So it'll be nice to be able to have a power supply that can just stay permanently out. And of course the box is the power switch. Okay, well, not the greatest video, I understand that, but I just wanted to share with people what I've got going here, and hope you have a happy new year.